Hello friends. Today's project is about FPGA motor control. So in this tutorial, we'll learn how to control motor or how to start with motor rotation of motor with FPGA control and as well as with PIC controller, that is a microcontroller. So first of all, there is the block diagram where we can use any of FPGA board. Then we need one power stage, that is of motor control. We'll use one IC. Then there is our VLDC or any motor, DC motor, simple DC motor. So we'll use this block diagram for. We will not use this analog design and position signals, that is that will be encoder. So in first stage we don't need these things. In my next future videos we will step forward to this direction. So let's start. We'll use any FPGA board that would be our power stage, that power stage amplifier circuit, and that would be our motor, any DC motor, where through this circuit diagram we can control the motor through FPGA and PIC controller. So today in this tutorial, first of all we will design one circuit diagram in Proteus. So I will teach you how to design one motor control through PIC controller. Then we will generate code in FPGA, and so you will be learning designing circuit in Proteus first of all. So first of all we will open Proteus, a professional. Now go to file, click next new project. So we shall give it motor control. Okay, next project, new project, click next. We'll use not get schematic, click next. Not get PCB, next. No firmware, we'll generate by our own and finish. Okay, there's the panel. Here it comes. Now we'll add simply all the peripherals we need. First of all we'll go to here, we'll go to PIC, and here we'll search for motor. Here you can see that simple. First of all we'll use simple DC motor. So take this one, click OK. So I am placing this. So we need motor, so we are using this motor again. Now go to, I need one this power stage amplifier thing which will give the power to the motor. So we'll select this. Now go to here. The IC will be using L9 110, this IC. This is basically one edge bridge circuit. Then we need one controller. Here as in Proteus we don't have any FPGA, so we'll use PIC controller, PIC 18F4520. I'm going to use this thing, and here we'll use this QFP package. Okay, this is the controller. So for this we need one crystal. It would be crystal. I'm using this. Here I'm connecting. We need LCD display. So I'm going here this display. So I'm putting it here. So through this display we can see in which direction we are moving the motor. Okay, so now we are going to add supply. Sorry, for that we will go there, this generator mode and DC. Okay, this one and the one for ground. Okay, now first of all we'll make it 5 volt. We'll just deselect it so that it will give us the name. Yes, 5 volt. We'll connect it to the DC. This will again we'll use 5 volt. So we'll connect it to MCLR. And then okay, this I'm going to use as ground. Sorry. Okay, so first of all give supply to this. Here I'm going to supply and connecting ground to this ground pin, as I have given 0 volt here. Then I am connecting motor signals, the output A and output B. This will be connected to the motor terminals. Any terminal you can use. Then I am going to use this input signals IA to RB7 and this IB to RB6. Now I will add this crystal, so crystal will be connected to here, and again I'm connecting this, and the frequency we are using 4 MHz. That's enough. Now this is the display. We will connect these displays. This is the VSS, that would be ground, and we are connecting this to ground. The VDD we are giving to 5 volt. For V we need potentiometer, so again we'll go to component. This here will give potentiometer. We'll select active pot, so we'll place this here. Okay, now we'll connect the terminal to one terminal to 5 volt, another terminal to ground, and this control pin will be connected to VE. That's it. Now RS pin will connect to RB5. REP enable pin I am connecting to RB4, and the read write pin I am connecting it to ground, because we'll enable this as a write mode. Now as whatever program we are going to write is 4-bit, so D0 to D4 I am connecting to ground, and D7 to D4 I am connecting to this port Bs. And now I am connecting D7 to RB3, RB2 to RB6, RB5 to RB1, and D4 to RB0. That's all we have connected. Now we first of all save it. Now our main thing is we need code here, program file. So we need program file to write. Let's start it. So for that we will use MikroC-Pro. So let's open that. This is the MikroC-Pro where we can is here we have selected this PIC 18F4520, so crystal frequency 4 megahertz. Already I have written the code to save the time, so here I'm just giving you the brief. So these are our port selections. For this code file, I will give that in the description box I have given you the link. So through this link you can download it, or simply you just comment, make a comment for this code file. I'll share with you. So this is the LCD library where I'm going to use LCD initialization, then LCD command for clear, LCD command cursor off, LCD out. Through this command will give data to the LCD. So as we see that we have given two pins are there, two pins are connected over there. So through this pin, when we will give 1 to this pin IA and 0 to IB, so it will rotate in right direction, and we will give 0 to I pin and 1 to IB pin, so motor will rotate in reverse direction, in left direction. So that will be displayed here. So in my code also I have written like that. Initially so initially the text 6 whatever we have made here, text 5 is rotation right and text 6 is rotation left. So initially we are giving RB7 to 1 and RBC6 to 0. So here you can see this RB6 and RB7, both of them are connected. RB6 and RB6, both of them are connected here. RB6 and RB7 are connected there. So 1 and 0, and it will be stayed there for 1 second. So it will be rotating in the right direction for 1 second. Then I have given both the pins 0 0, so it will be stopped. Then again it will be stopped for 1 second. Then I'm clearing the display and giving text 5, that is rotation left. So and I'm giving again port B0 and port B61. Initially it was 10, now I'm giving 01, and it will be like that for 1 second. So it will be rotating in left direction for 1 second. Again I'm giving 00 for 1 second, so it will be stopped, and then again it will go to this loop and it will rotate in right direction again. So after writing this code, we'll go this Proteus and we'll add that program file. Go to wherever I have stored it. So this is the file, hex file I'm adding here. So I have added this. Now we'll simply run it. So here we can see that it is rotating in right direction, so it is showing right, and in left direction it is showing left. So the speed is slow, so we can increase that speed by increasing the voltage. So we'll just increase the voltage. So let's make it 15 volt. And now, so after increasing the voltage value, we'll simply run it. Now so we can see speed has been increased. That's the project. Thank you so much. In this way we can control the motor. Now that was generated by PIC controller. Now I'll show you how to create this thing, this code in FPGA. Let's start. So now we are going to write the code in FPGA. So for coding, for compilation, we going to use Vivado software. If you want to use ISE, then you can use ISE for lower versions of FPGAs. So we are in Vivado. First go to project, then create new. Next, give it a name motor. Next, multi project. Next, we'll give it VHDL, create file, give it a name motor. Next, we are not going to use any constant right now. Click next. Then board, whatever board you have, you select according to that. Now I'm going to use my Saturn board, so I'm using this. Click finish. So here is the VHDL file. Here already I have some predefined code, so I'm just pasting it. Now I'm going to explain the code. First of all, I'm going to use some one clock through this here input is clock. Through this clock we will process our logics. So in my board the input clock is 100 megahertz. So for 1 second delay for the pulses we will be creating, so we'll have to divide this input clock. So we'll be generating this output signals. Let's see, let's have we have defined two clock out signals, signal out 1, signal out 2. As if we open the Proteus design, we can see these two signals. Let's give it a name, signal out 1, signal out 2, and these are the signals, signal out 1, signal out 2. So we'll be creating here. Now these are the some variables we are taking here. Now this is the function of clock division. So my if my input clock is 1 megahertz, some clock frequency is 1 megahertz, so by dividing it 499, so and 499 plus 1 is 500 into 2, this 1000. So 1 megahertz divided by 1000, that will be 1 kilohertz signal. So the clock out signal will be 1 kilohertz, and again I am dividing it 1 kilohertz signal to 1 hertz signal. So again through this division factor I'm going to divide it into to generate 1 hertz signal. So 1 kilohertz divided by 1000, that would be 1 hertz signal, and through this I'm going to generate this one, signal out 1 and signal out 2. For this code also, please make comment in the comment section, so I will be sharing I'll share you with the codes. Now in the Proteus design, let's have a look what are the signals we are getting here. So we'll add this actual is oscilloscope. So oscilloscope I'm going to adding here. a signal. So now if I run it, so this is my signal. So you can see these signals are there. So when it is on, so it is off, and this is after 0 second it is off, then it is on. In this way only we will be creating the signal in the FPGA. Now these are signal. So I have generated it. Now let's synthesize it first of all. Let's synthesize it. So synthesis is successfully completed. Now we will run simulation. First it will appear like that. So we'll just we'll only keep those files. Rest of the things we'll delete. Now in the clock, let's give it force clock. So the leading edge value will give 1, trailing value will give 0, and we are going to take this as a 1 megahertz signal. So this period is 1000 nanoseconds. So 1 megahertz signal clock will be generated. Now, so when I start simulation, so graph appears like that. So in the signal out 1 and signal out 2, so it is 1, and it is when it is 1 it is 0, when signal out 2 is 1, signal out 1 is 0. So in this way, in this condition, motor rotates in right direction. In this period, motor rotates in left direction. So if I stop this, we can see the marker that is for 2000 millisecond to thickness of this is of 500. Now another one, so it is of around 500 milliseconds. So in one I've generated for 500 millisecond pulse. So in 1 second, two times motor will change its direction. So this is the thing. This way you can control the motor in reverse or forward direction. So that's it. Hope you liked it, and if you like my video tutorial, please like and subscribe my channel. Thank you.